Hello everyone, I am Faranjum from Sri Venkateshwara College of Engineering, Bangalore. The topic for the presentation is pointer aliasing from the course Microcontroller and Embedded System. The contents of this presentation are: what is an embedded system, real-time applications of embedded systems, characteristics, advantages and disadvantages of embedded system, what is pointer aliasing, the examples where pointer aliasing can be seen, how pointer aliasing can inhibit compiler optimizations, and how to avoid aliasing. First, what is an embedded system? An embedded system is a microcontroller or a microprocessor based system which is designed to perform a specific task. For example, a fire alarm is an embedded system, it will sense only smoke. An embedded system has three components: hardware, application software, and real time operating system. The real time applications of embedded systems, where embedded systems is used in real life: traffic management, security system, printer, oven, audio system, television, fax machine, washing machines, etc. The characteristics of an embedded system: it is single function, it performs a single specialized operation and repeats the same. Tightly constrained, it is tightly constrained in implementation of features like cost, size, power, and performance. Reactive and real time, it is reactive to all the changes and applicable in real time or real life. It is microprocessor based, it has memory as its software is embedded in ROM. The advantages of embedded system are: it is easily customizable, it has low power consumption, it has low cost, and has enhanced performance. Disadvantages of embedded system is: it has high development effort and it takes larger time to market. Before going to the main topic, pointer aliasing, we will see what is a pointer. A pointer is defined as a derived data type that can store the address of other variables or a memory location. Features of the pointers: pointer saves the memory space. The execution time of a pointer is faster because it directly accesses to memory location. The memory is accessed efficiently with the help of a pointer. Memory is allocated and deallocated dynamically. Pointers are used with data structures. The uses of pointer are: for passing the argument by using references, for accessing the elements of an array, for dynamic memory allocation by using the functions called malloc and killoc. They are used in arrays and functions to improve the performance of code, for returning multiple values, for implementing a data structure, and for doing system level programming. In pointer aliasing, first we will see what is aliasing. It is described as a situation in which a data location in memory can be accessed through different symbolic names in the program. Pointer aliasing. Two pointers are set to alias when they point to the same address. If you write to one pointer, it will affect the value you from the other pointer. For example, if a function has two pointers, PA and PB, with the same value, we say the pointers alias each other. This introduces constraints on the order of instruction execution. If two write accesses that alias occur in program order, they must happen in the same order on the processor and cannot be reordered. This is also the case for a write followed by a read or a read followed by a write. Two read accesses to aliases are safe to reorder. Because any pointer could alias any other pointer in C, the compiler must assume that the program regions accessed through these pointers can overlap, which prevents many possible optimizations. C++ enables more optimizations as pointer arguments will not be treated as possible aliases if they point to different types. C99 introduces the restrict keyword that specifies that a particular pointer argument does not alias any other. If you know that pointers do not overlap, using this keyword to give the compiler this information can yield significant improvements. However, misusing it can lead to incorrect program function. The restrict keyword qualifies the pointer and not the object being pointed to. This consideration is not specific to the ARM architecture. When using GCC compiler, you can enable the C99 standard by adding std equal to C99 to your compilation flags. Now, let us see an example for pointer aliasing. In this simple program, we have declared a variable a whose value is 10 and also a pointer p which holds the address of the variable a. Let us assume the address of variable a is 100. The first print statement prints the value of a, which is 10. Second print statement prints the value of asterisk p, which here asterisk means the value of the operator. So it prints the value of a, which is 10. Third print statement says to print the ampersand a. Ampersand here indicates the address of the operator. So it indicates the address of a, which is 100. Fourth print statement says to print p. P holds the address of the variable a, hence it prints 100. Here the variable a and asterisk p alias each other and the variable ampersand a and p alias each other. Let us see another example for pointer aliasing. The code is as follows. The following function increment two timer values by a step amount. Note that the compiler loads from step twice. Usually a compiler optimization called common sub-expression elimination would kick in so that the step was only evaluated once and the value reused for the second occurrence. However, the compiler can't use this optimization here. The pointers timer 1 and step might alias one another. In other words, the compiler cannot be sure that the write to timer 1 doesn't affect the read from step. In this case, the second value of step is different from the first and has the value timer 1. This forces the compiler to insert an extra load instruction. The same problem occurs if you use structure accesses rather than direct pointer accesses. The following code also compiles inefficiently. The compiler evaluates state of step twice in case state of step and timers of timer 1 are at the same memory address. The fix is easy. Create a new local variable to hold the value of state of step so that the compiler only performs a single load. Now, let us see how pointer aliasing can inhibit compiler optimizations. In most of the situations, a compiler cannot tell whether two or more pointers point to the same address in memory or it points to two different addresses. The compiler itself needs to make the safe choice, so it will often default to assume that the pointers do alias, even when the programmer knows that the pointers do not. A bigger problem with aliasing is that it often inhibits the compiler's ability to perform complex transformations of the code. Once a code has more than two streams of input data, it becomes very difficult to produce runtime code that dynamically checks for the aliasing issues. How to avoid aliasing? We can avoid aliasing by not relying on the compiler to eliminate the common sub-expressions involving the memory accesses. Instead, we can create new local variables to hold the expression. This ensures that the expression is evaluated only once. Also, avoid taking the address of local variables. The variable may be inefficient to access from then on. Strict aliasing rule. It is a situation in which the C compiler makes an assumption that the pointers of different types will never point to the same memory location, that is, alias of each other. Thank you so much for watching the video.